grade for the sake of this assignment. We're going to focus on 7th grade. And here's what we see. In 2016, whoa, 83,509 7th graders took the AZ Merit Test. 83,000 kids. Now, here's the idea behind this in terms of we see something in the world, a kind of a natural phenomenon that when you have lots of data, like 83,509 would be a pretty large data set. When you have that much data, what you see is, if you looked at these scores, there's some low scores and there's some high scores. But in terms of the number of kids, not that many kids score low, and not that many kids score high. Most kids score somewhere in the middle. What we create here is what's called a normal distribution. Now, there's other kinds of distributions in different settings that we're not going to study. We're going to study this idea of a normal distribution is the phrase or the terminology behind this. Sometimes we refer to this as a bell curve. Maybe you've heard of that, the bell curve. And if you've paid attention to any of this COVID stuff, we see it a lot. So in the COVID stuff, it would look like this. Say a month ago or so, there was not that many cases of COVID. Then the number of cases has been increasing faster and faster. I keep getting that. Faster and faster and faster. Let me try that again. Increasing faster and faster and faster. We're hoping, maybe we're getting close, that number is going to peak. And then what we hope is, for most cases, although the death rate is like, you know, whatever it is, for most cases, though, these people are going to recover. Well, wow, I don't know what I'm doing to make that happen. So what we see is this same phenomenon, this bell curve. And you've heard the phrase, flatten the curve. We don't want that peak to be so high, so fast, so condensed that everyone's in the hospital, overwhelming the hospitals and the ventilators and the masks and the PPEs and all that stuff. We want that curve to do, it's going to do that no matter what. We want that peak to be shorter and more spread out so that it doesn't inundate our healthcare system. Normal distribution, we see it in all kinds of things, including AZ Merit Test scores. So what you're going to do on this assignment that you'll submit is you will examine just grade 7 and notice, thank you to the Arizona Department of Education, they gave us the mean score and they gave us the standard deviation. They also gave us the lowest score and the maximum score, but you don't really need that for this task. We just need the mean and the standard deviation. Now on this task on Canvas, I've given you a link to this website where you can do what you need to do without lots of computations. You go to this website and you type in the mean, you type in the standard deviation, and it creates the normal distribution, the bell curve. So right here in the middle is that mean of 31.61. And then if you add one standard deviation, one sigma is the Greek letter we use for that, and then you add another standard deviation, another 37.4, you get to here. And if you added a third one, they didn't do it in this chart, but you would get out to here, add another 37.4, or go this way, subtract one standard deviation, subtract 37.4, you get to 3594.4. Standard deviation, you get to this number, subtract a third standard deviation, you get to this number. So most students, like 99.9% of the scores are going to fall between 3519.41 and whatever this number is over here that I didn't get my clipping here. What you're going to do is this. When the state of Arizona reports it for the news, they usually give you this. What percentage of students were proficient as measured by this test? And you see in grade 3, apparently it was 33%. But how do they do that? I want you to have some experience and some knowledge about how they do that. Here's how they do that. So what I've asked you to do in this task is first figure out what percentage of the students were minimally proficient. So using this app over here, you'll notice that to be minimally proficient in grade 7, a student would have to score between 35.29 and 36.28. I did over here, you guys will have to do this on this app, click the between, and then there's 35.29 and there's 36.28. So the graph then will show you there's 35.29 and there's 36.28. So all the students who scored in there are represented in this part of the bell curve. And the computer then will tell you what percentage that is. Notice it's just left of half. About half are on the gray side, half are on the non-grayed inside. It's actually, if you look down there at the bottom, about 46%. So you will claim that 46% of 7th graders on the AZ Merit in 2016 anyway, were minimally proficient. And you'll do the same thing for partially proficient, 36.29 to 36.51. Same kind of deal. Come in here and put, hey, how many people were between 36.29 and 36.51? And the graph will update. So there's 36.29, there's 36.51, and notice it's a lot fewer people were in there. In fact, it's about 23%. And then you'll do that for proficient, and you'll do that for highly proficient. And you'll report, what you'll submit to me is what percentage of students in grade 7 in 2016 are each of the proficiencies, minimally, partially, proficient, highly proficient, back in 2016. To make it more interesting, I want to kind of get your brain, put your brain on for a moment and think about this. Suppose you're at a school, you're teaching at a school and you're a 7th grade math teacher. Not a nightmare. Saying some people do this. And I want you to play for a minute and figure out, suppose the school sets a goal, which they do, by the way. Schools will set goals and say something like, we want it to be that 75%, our school is better than 75% of the schools in Arizona. What score would we have to attain for that to happen? So notice what I've done here, just to give you an idea. I don't have the right answer here, you guys. This is not the right answer. I want you to figure out the right answer, but just give you an idea. If our school is better than 75%, then we need a score I gotta figure this thing out. We want to score such that 75% of the schools are below our score. That would put us better than 75%. So that's fine. I'm going to play. You're going to put in a score. I just picked 36.50. 36.50 is about there, and I thought, hey, maybe that'll get me close so that everybody else is below me. 75% is below me. Well, I didn't get it. I got 68.85%. So you're going to have to play a little bit. Play around until you get this percentage down here to be 75%, and then this would be the score that would have accomplished that. And then suppose you and your school, grade 7 again, has the same score in 2017 as it did in 2016, as you determined in the previous problem, this 75% deal. But the standard deviation increased by 10 points. Now, you guys, standard deviation is all about spread. So a smaller standard deviation means that the scores are more clustered around the mean. A higher standard deviation means things got spread out around the mean. What if your school's score stayed the same on average? The standard deviation got higher. Things got more spread out. This is an important thing because this happens to schools all the time. They'll compare year to year to year, and all they'll look at is their score. And they'll say, oh, our score didn't change at all. But what about the standard deviation? Take a look. Just as my example, remember my 3650 and that 68.85%? What if the standard deviation wasn't 37.4, but 47.4? What if we spread things out more? Look what happens. We now are scoring above only 65% instead of 68, almost 69. Even though our scores didn't change, our comparison, because of the standard deviation, does change from being better than 60, almost 69%, only being better than 65%. I want you to play. Now you guys are going to use this app. It's not going to be heavily computational. Use this app to help you think through these things and practice just making sense of a normal distribution situation.